And now in this lecture we will find out the area of the green semicircle using two different methods. In the drawing we have two semicircles. This is the white semicircle, this is the green semicircle. In addition we know that this is line segment AC, that is equals to 5 units in its length. This is line segment CB, that is equals to 1 unit in its length. Again, our mission is to find out the area of this green semicircle. Okay, so we start with the first method, and we'll join points P and B together by a straight line. And I will copy the white semicircle in a new page, and we will implement rule 7 in the white semicircle. So actually, this is the white semicircle that I copied from the original drawing. Here AB is the diameter of the white semicircle, so I write it down. And by joining points P and B together by a straight line, we created the peripheral angle APB. This is peripheral angle APB, and peripheral angle APB is subtended on AB, that is the diameter of the white semicircle. So here we can implement rule 7. I'll repeat quickly on rule 7. According to rule 7, if a peripheral angle subtends on the diameter of the circle, then it is equal to 90 degrees. So in the drawing we have a circle, and line segment AB is the diameter of this circle, and we have also peripheral angle ACB that is subtended on AB, that is the diameter of this circle, and therefore peripheral angle ACB equals to 90 degrees in its size. So whenever you have a peripheral angle that is subtended on the diameter of the circle, it is equals to 90 degrees in its size. We can implement rule 7 in our drawing. Why? Because in our drawing we have peripheral angle APB that is subtended on AB, that is the diameter of this white semicircle. Therefore peripheral angle APB equals to 90 degrees in its size, according to rule 7. In the next step, we will join points P and C together by a straight line. and I will copy the green semicircle in a new page and will implement rule 7 on the green semicircle. Actually, this is the green semicircle that I go to on the original drawing. AP is the diameter of the green semicircle. So I write it down. Line segment AP is the diameter of the green semicircle. Actually, by joining points P and C together by a straight line, we can deduce peripheral angle ACP. This is peripheral angle ACP, and this peripheral angle ACP is obtained on AB, that is the diameter of this green semicircle. Therefore, peripheral angle ACP must be equal to 90 degrees in its size. Peripheral angle ACP equals to 90 degrees in its size. It is a right angle. According to rule 7. In the original drawing, it is very easy to see that this angle A, this is angle A, that is a common angle. It belongs both to the green triangle PAC, and this angle A also belongs to triangle PAB. So angle A is a common angle that belongs to both triangles. So we will define the size of the common angle. This common angle, angle A, is alpha. So this is angle A. It is defined as alpha. So in triangle, the right triangle APB, this angle equals to alpha, this angle equals to 90 degrees. Therefore, this third missing angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees This equals to 180 degrees. That is the sum of the angles in a triangle. Likewise, here, this is the common angle, angle A, that is equals to alpha, according to our definition. In the green triangle ACP, this angle equals to alpha, this angle equals to 90 degrees. Therefore, this first recent angle must be equal to 90 degrees minus alpha. In the next step, I will copy this green right triangle ACP and also this white triangle APB in a new page, and we will prove that those two right triangles are similar to each other according to angle similarity rule. So those are the two right triangles that I copied from the original drawing. In the next step, we prove that those two right triangles are similar to each other according to angle similarity rule. So we prove that this triangle APB, the right triangle APB, is similar to this green right triangle APC. So why those two right triangles are similar to each other? First of all, those two angles, they are both equal to 90 degrees, therefore they are equal to each other. So actually this is angle APB in the right triangle APB. And it is equal to this angle in the green triangle APC. This is angle ACP. Repeat again, found out actually that angle APB, the right triangle APB equals to angle ACP in the green triangle APC, they are both equal to 90 degrees, therefore they are equal to each other. In addition, this is angle alpha, that is a common angle, it belongs to both triangles. We have angle alpha here also. So angle alpha is a common angle that belongs to both triangles, so we can write down that angle alpha equals to itself. So if we relate to angle alpha, as it belongs to the white triangle, this white triangle, it will be defined as angle PAB. And it is equals to angle to itself. So if we relate to angle alpha as it belongs to this green triangle, it will be defined as angle PAC. Repeat again. This equation means that angle alpha equals to itself. We just call to angle alpha two different names. So angle alpha equals to itself. It's a common angle that belongs to both triangles. And finally, those two angles, they are both equal to 90 degrees minus alpha, therefore they are equal to each other. So this is angle ABP in the white triangle APB, and it is equal to this angle, that is actually angle APC in the green triangle APC. Repeat again. Angle ABP in the white triangle equals to angle APC in the green triangle. They are both equal to 90 degrees minus alpha, therefore they are equal to each other. So we actually proved that all the figures in this white triangle APB are correspondingly equal to all the figures in this green triangle APC. Therefore, those two white triangles are similar to each other according to angle similarity rule. So I write it down. So I actually found out that the white triangle APB is similar, this is the sign of similar, to the green triangle APC according to angle similarity rule. And for the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. We derive that side AB in this right triangle APB over side AP in this green triangle equals to side AP in this white triangle over side AC in this green triangle. Repeat again. We derive that side AB in the white triangle over side AP in the green triangle equals to side AP in the white triangle over side AC in the green triangle. what is the length of AB? From the drawing, it is very easy to see that AB in total equals to 5 plus 1, that is 6. Again, AB equals to 5 plus 1, that is 6. Over AP. AP is the missing side, so we leave it as it is. And it is equals to side AP over side AC. AC equals to 5. So if I found out that in total 6 over AP equals to AP over 5. Here we cross multiply this equation. And we get that 5 times 6 is 30 equals to AP times AP, that is AP squared. So if I found out that AP squared equals to 30, we take a root out of this equation. And finally, we get that the missing side AP equals to the square root of 30 units in its length. So actually, this is the missing side AP, and this is equals to the square root of 30 units in its length. We already found out that AP is the diameter of this green semicircle. Again, AP is the diameter of this green semicircle. Therefore, AP over 2 is the radius of this green semicircle. So I write it down. So the radius R of this green semicircle equals to the diameter AP over 2. So the radius R equals to AP, that is square root of 30 over 2. So in total, we actually found out that the radius R of this green semicircle equals to the square root of 30 over 2. I repeat again that our mission is to find out the area of this green semicircle. The area of this green semicircle equals to, of course, pi r squared over 2. So I write it down. The area of this green semicircle equals to pi r squared over 2. So it is pi, and we just right now found out that r, that is the radius of this green semicircle, equals to the square root of 30 over 2. Therefore, r squared is square root of 30 over 2 squared divided by 2. So the area of the green semicircle equals to pi, and square root of 30 squared is 30, over 2 squared is 4, divided by 2. So the area of the green semicircle equals to pi times 30 over 4 over 2 is 30 over 4 times 2. So the area of the green semicircle equals to pi, and here we have 30 over 2 is 15. So in total, this expression equals to 15 pi over 4. 15 over 4 is 3.75, so in total this expression equals to 3.75 pi. And in terms of numbers, 3.75 pi is 11.78. So in conclusion, we should found out that the area of the green semicircle equals to either 3.75 pi square units, or in terms of numbers is equals to 11.78 square units. Repeat again. Area of this green semicircle equals to either 3.75 pi square units, or in terms of numbers, the area of this green semicircle equals to 11.78 square units. We finished with the first method. In the next step, I will present to you how to find out the area of this green semicircle according to the second method. In the second method, we'll join points P and B together by a straight line. So in the next step, I'll copy this white semicircle in a new page, and again we will implement rule 7 on the white semicircle exactly as we did in the first method. Okay, this is the white semicircle that I copied from the original drawing. We already found out that we know that AB is the diameter of this white semicircle, so I write it down. Actually, by joining points P and B together by a straight line, we created a peripheral angle APB. This is peripheral angle APB. Peripheral angle APB is subtended on AB, that is the diameter of this white semicircle. And therefore, according to rule 7, peripheral angle APB must be equal to 90 degrees in size. So this is peripheral angle APB. That is a right angle, according to rule 7. That is to say, line 7 BP is perpendicular to line 7 PA. Again, because of the fact that peripheral angle APB equals to 90 degrees in its size, it means that line 7 BP is perpendicular to line 7 PA. So here, this is peripheral angle APB, that is a right angle. Peripheral angle APB is a right angle. It means that line segment BP is perpendicular to line segment PA. But PA is the diameter of this green semicircle, and we know that the center of any circle is located on the diameter of the circle. Again, the center of any circle is located on the diameter of the circle. AP is the diameter, so the center of the green circle must be located on AP, that is the diameter of the circle. So this is point O, that is the diameter of this green semicircle. Again, point O is the center of this green semicircle. It is located on AP, that is the diameter of the green semicircle. So point O is the center of this green semicircle. Point P is the point on the green semicircle itself. Therefore, PO is the radius of this green semicircle. We define the radius of this green semicircle as R. Therefore, PO equals to R. We know that BP is perpendicular to PA. If BP is perpendicular to PA, BP must be also perpendicular to PO. One could, if you have a line segment that is perpendicular to a straight line, then it must be perpendicular to the part of the straight line. Okay? Therefore, line segment BP also perpendicular to PO. That is the radius of this green semicircle. So, line segment BP is perpendicular to the radius PO of this green semicircle. And whenever you have a line segment that is perpendicular to the radius of the circle or the radius of the semicircle, you can implement all one. Okay, I'll press quickly on all one. According to rule 1, a tangent to the circle is perpendicular to the radius drawn to its point of tendency. So in the drawing we have a circle. Here, this is the radius OM, that's equal to R. Here, line segment AB is perpendicular to the radius MO, that is R. Again, line segment AB is perpendicular to MO, that is the radius of this circle. Or line segment AB is perpendicular to the radius of this circle, and therefore, according to all one, actually any line segment that is perpendicular to the radius of the circle, it is defined as a tangent. Therefore, AB is a tangent to this circle at point M. So whenever you have a line segment that is perpendicular to the radius, then the line segment must be defined as a tangent to the circle. We can actually implement all one in our drawing. Why? Because in our drawing we have line segment BP that is perpendicular to the radius PO of this green semicircle, and therefore according to all one, line segment BP is tangent to this green semicircle, and the point of tendency is located at point P. Again, because of the fact that line segment BP is perpendicular to the radius R of this green semicircle, line segment BP is tangent to this green semicircle. And the point of tendency is at point P. So, from the common standpoint, point B, we have tangent BP to this green semicircle, and from the same common standpoint, point B, if we draw a straight line towards this green semicircle, it will cut this green semicircle at point C and point A. So for the same common standpoint, point B, we have also chord CA. Again, from common standpoint, point B, we have tangent BP to this green semicircle that is tangent to this green semicircle at point P, and from the same common standpoint point B, we have here chord CA. Therefore, we can implement here rule 10. I'll repeat quickly on rule 10. Rule 10 is true in any circle. So in any circle, if AB is any chord, you can see that AB is the chord of this circle, and PT is a tangent to the circle. Here, from the common standpoint point P, we have chord AB, and we also have tangent PT that is tangent to this circle at point T. Then in this moment, the following equation is true, that PT square equals to PA times PB. Again, PT square equals to PA times PB. We can definitely implement rule 10 in our drawing. Why? Because in our drawing, if you focus on this common standpoint point B, from this common standpoint point B, we have tangent BP to this green semicircle that is tangent to the green semicircle at this point P. In addition, from the same common standpoint point B, we have here chord CA of this green semicircle. So all the requirements of rule 10 are satisfied, and therefore we can implement here rule 10. According to rule 10, we get that BP square equals to BC times BA. Again, BP square equals to BC times BA. So I write it now. According to rule 10, if we focus on the common standpoint point B, we get that BP square equals to BC times BA. So repeat again that if we focus on the common standpoint point B, the following equation will be true according to rule 10. Then BP square equals to BC times BA. Okay, this equation is the implementation of rule 10 in our drawing. BP is the missing tangent, so we leave it as it is. So BP square equals to BC. BC is 1, so we substitute BC by 1 times BA. BA in total equals to 5 plus 1, that is 6. Again, BA in total equals to 6. 5 plus 1, that is 6. So according to rule 10, we actually found out that BP square equals to 1 times 6, that is 6. So BP square equals to 6. We take a root out of this equation, and finally we get that the missing tangent BP equals to the square root of 6 units in its length. So this is the missing tangent BP is equals to the square root of 6 units in its length. In the next step, I will copy the right triangle APB in the new page, and we will implement the Pythagoras theorem on this right triangle APB. Side AB equals to 6 units, side PB equals to the square root of 6 units, and the only missing side is side AP. So actually, this is the right triangle APB. Is the curve between the original drawing. So only mentioned before, side AB equals, the opposite AB equals to 6 units inside, side PB equals to the square root of 6 units inside, and the only missing side is side AP. According to the Pythagoras theorem, in any right triangle, the square of the opposite equals to the sum of the squares of the perpendiculars. The hypotenuse on this right triangle APB is AB, therefore the square of the hypotenuse is AB squared, and it must be equal to AP squared plus PB squared. So let it know, according to the Pythagoras theorem, in this right triangle APB, AB squared, that is the square of the hypotenuse, must be equal to AP squared plus PB squared. The hypotenuse AB equals to 6, therefore AB squared is 6 squared, that is 36. And it is equal to AP squared. AP is the missing side, so we leave it as it is. Plus PB squared. PB equals to the square root of 6 units inside, so therefore PB squared is square root of 6 squared, that is 6. So in total, we should find out that 36 equals to AP squared plus 6. We subtract 6 from this equation, finding out that the missing side AP squared equals to 36 minus 6 is 30. We take a root out of this equation, and finding out that the missing side AP equals to the square root of 30 units in its length. Okay. This is the missing side AP. Is equals to the square root of 30 units in its length. AP is the diameter of this green semicircle. If the diameter AP equals to square root of 30 units, it means that the radius must be equal to half of it. The radius R is AP over 2. So the radius R of the green semicircle equals to the diameter AP over 2. AP is square root of 30, so square root of 30 over 2 is the radius R. So in conclusion, we should find out that the radius R of the green semicircle equals to the square root of 30 over 2. Our mission is to find out the area of this green semicircle. The area of this green semicircle equals to pi r squared over 2. So write it down. The area of the green semicircle equals to pi r squared over 2. So it is equals to pi, and r is equal to 30 over 2. Therefore r squared is equal to 30 over 2 squared divided by 2. So the area of the green semicircle in total equals to pi. Here we have square root of 30 squared, that is 30, over 2 squared, that is 4, divided by 2. So the area of the green semicircle equals to pi times 30 over 4 over 2 is 30 over 4 times 2. So the area of the green semicircle equals to, here we have 30 over 2 is 15. So in total, the value of this expression is 15 pi over 4. Here 15 over 4 is 3.75. So in total, the value of this expression is 3.75 pi, and 3.75 pi is 11.78. So in conclusion, we actually found out that according to the second method, the area of the green semicircle is equals to either 3.75 pi square units, or in terms of numbers, is equals to 11.78 square units, and the result is the same result as we write in the first method. So in both methods we have found out that the area of this green semicircle equals to either 3.75 pi square units, or in terms of numbers, the area of this green semicircle equals to 11.78 square units. So in the next step, I'll summarize the lecture. We start with the first method, of course. In this lecture, we found out the area of this green semicircle using two different methods. We start with the first method. So in the drawing we have two semicircles. In addition, we know that this is 97AC, this equals to 5 units in its length. This is 97CB, that equals to 1 unit in its length. Again, our mission is to find out the area of this green semicircle. So first of all, we joined points P and B together by a straight line, and I copied this white semicircle in a new page, and we implemented rule 7 on the white semicircle. So actually, this is the white semicircle that I copied from the original drawing. Here, AB is the diameter of this white semicircle. AB is the diameter of the white semicircle. And by joining points P and B together by a straight line, we created here peripheral angle APB. This is peripheral angle APB, and it is subtended on AB, that is the diameter of this white semicircle. And according to rule 7, any peripheral angle that is subtended on the diameter of a circle or a semicircle must be equal to 90 degrees in its size. Therefore, peripheral angle APB it is a right angle according to rule 7. In the next step, we join points P and C together by a straight line, and I copied the green semicircle in a new page, and we implemented rule 7 on the green semicircle. This is the green semicircle that I copied from the original drawing. Again, here AP is the diameter of this green semicircle. AP is the diameter of the green semicircle. And by joining points P and C together by a straight line, we created here peripheral angle ACP. This is peripheral angle ACP, and it is subtended on AP, that is the diameter of this green semicircle. Therefore, peripheral angle ACP must be equal to 90 degrees in its size. According to rule 7, any peripheral angle that is subtended on the diameter of the circle must be equal to 90 degrees in its size. Therefore, peripheral angle ACP equals to 90 degrees. Yeah, this is the right angle. So if we look in the original drawing, this angle A is a common angle that belongs to both triangles. It belongs to the green triangle APC, and this angle A also belongs to triangle APB. Therefore, angle A is a common angle that belongs to both triangles. So we define the size of angle A as alpha. You can see angle A equals to alpha according to our definition. So here This is angle A. That is defined the second alpha. So in the right triangle APB, this angle equals to alpha, this angle equals to 90 degrees. Therefore, this third missing angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees. 90 degrees plus 90 degrees is equals to 180 degrees. That is the sum of the angles in any triangle. Likewise, this is angle A. That is equals to alpha according to our definition. This angle equals to 90 degrees according to rule 7. Therefore, in the ring triangle ACP, the missing third angle equals to 90 degrees minus alpha. Okay. So, in the next step, we prove that this right triangle APC, the right triangle APC, is similar to this right triangle APC according to angle similarity rule. So I copied those two right triangles in a new page and we prove that those two right triangles are similar to each other. So actually, those are the two right triangles that are copied from the original drawing. We prove that those two right triangles are similar to each other. So why those two right triangles are similar to each other? First of all, those two angles they are both equal to 90 degrees, therefore they are equal to each other. In addition, this is angle alpha, that is a common angle, it belongs to both triangles. We have angle alpha here also. So you can write down that angle alpha equals to itself as a common angle that belongs to both triangles. And finally, those two angles they are both equal to 90 degrees minus alpha, therefore they are equal to each other. So actually prove that all the three angles in the right triangle APB are correspondingly equal to all the three angles in this right triangle APC. Therefore, those two right triangles are similar to each other according to angle similarity rule. Repeat again, I can prove that the right triangle APB is similar to the green triangle APC according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. We derive that side AB this right triangle over side AP in this green triangle equals to side AP in this white triangle over side AC in this green triangle. Repeat again. We derive that side AB in the white triangle over side AP in the green triangle equals to side AP in the white triangle over side AC in the green triangle. What is the length of AB? AB in total equals to 5 plus 1, that is 6. Again, AB equals to 5 plus 1, that is 6. And AC equals to 5. So we substitute AB by 6 and AC by 5. AP is the missing side, so we leave it as it is. So in conclusion, we should found out that 6 over AP equals to AP over 5. Here we cross multiply this equation and found out actually 5 times 6 is 30, so 30 equals to AP times AP, that is AP squared. So 30 equals to AP squared. We took a root out of this equation and found out that the missing side AP equals to the square root of 30 units in its length. This is the missing side AP. This is equals to the square root of 30 units in its length. AP is the diameter of this green semicircle. So the diameter AP of this green semicircle equals to square root of 30, therefore the radius is AP over 2. Okay, the radius of this green semicircle is the diameter AP over 2. So the radius R of this green semicircle equals to the diameter AP over 2. The diameter AP is square root of 30, and square root of 30 over 2 is the radius of this green semicircle. In conclusion, we found out that the radius R of this green semicircle equals to the square root of 30 over 2. Our mission is to find out the area of this green semicircle. The area of this green semicircle equals to pi r square over 2. Repeat again. The area of the green semicircle, that is the area that we are looking for in this question, equals to pi r square over 2. So it is pi r, the radius of the green semicircle is equal to 30 over 2. Therefore r square is equal to 30 over 2 square divided by 2. So in total, the area of this green semicircle equals to pi, and square root of 30 square is 30, over 2 square is 4 divided by 2. So in total, the area of this green semicircle equals to pi times 30 over 4 over 2. 30 over 4 over 2 is 30 over 4 times 2. So in total, the area of the green semicircle equals to 30 pi over 4 times 2. 30 over 2 is 15. So in total, the value of this expression equals to 15 pi over 4. 15 over 4 is 3.75. Therefore, in total, the value of this expression is 3.75 pi. 3.75 pi is 11.78. So in conclusion, we found out that the area of this green semicircle equals to either 3.75 pi square units, or in terms of numbers, it is equals to 11.78 square units. We finished with the first method. In the next step, I actually presented to you how to find out the area of this green semicircle according to the second method. In the second method, we join points P and B together by a straight line. Then I copied this white semicircle in a new page, and we implemented rule 7 on this white semicircle. Okay, this is the white semicircle that I copied from the original drawing. Again, 8B is the diameter of this white semicircle. By joining points P and B together by a straight line, we created peripheral angle APB. This peripheral angle APB is subtended on AB, that is the diameter of this white semicircle, and according to rule 7, any peripheral angle that is subtended on the diameter of the circle or a semicircle must be equal to 90 degrees in its size. Therefore, peripheral angle APB equals to 90 degrees in its size. Here you can see that is a right angle. So actually, peripheral angle APB is a right angle. That is to say, line segment BP is perpendicular to line segment PA. So here, this is peripheral angle APB. That is a right angle. That is to say, line segment BP is perpendicular to line segment PA. PA is the diameter of this green semicircle, and you know that the center of any circle or semicircle must be located somewhere on the between points P and A, that is between the diameter, on the diameter. PA is the diameter, and the center of any circle or semicircle must be located on the diameter. So here we found out actually this is point O, that is the center of this green semicircle. So point O is the center of the green semicircle. Point P is the point on the green semicircle itself. Therefore, PO is the radius of this green semicircle. We define the radius PO as R. So R is the radius of this green semicircle. So in conclusion, we found out that line segment BP is perpendicular to the radius PO of this green semicircle. Again, line segment BP is perpendicular to the radius R of this green semicircle. And therefore, we can implement here rule 1. Whenever you have line segment that is perpendicular to the radius, then you can implement rule 1. I'll repeat quickly on rule 1. According to rule 1, a tangent to the circle is perpendicular to the radius drawn to its point of tendency. So in the domain we have a circle. OM is the radius R of this circle, and we have line segment AB is perpendicular to the radius MO. Again, line segment AB is perpendicular to the radius MO, and therefore line segment AB is defined as a tangent to this circle. Line segment AB is tangent to this circle at point M. So according to rule 1, whenever you have a line segment that is perpendicular to the radius, this line segment must be defined as a tangent to this circle. That is to say, AB is tangent to this circle at point M. We can definitely implement rule 1 in our drawing. Why? Because in our drawing we have line segment BP that is perpendicular to the radius R of this green semicircle. Therefore, according to rule 1, line segment BP must be defined as a tangent to this green semicircle. Actually, line segment BP is tangent to this green semicircle at point P. Okay, so from the common example point B, we have tangent BP that is tangent to this green semicircle at point P. And from the same common example point B, actually, if we draw a straight line towards this green semicircle, it will cut this green semicircle at 2 points C and A. So from the same common example point B, we have also chord CA. Again, from the common example point B, we have tangent BP, and we also have here chord CA. Therefore, we can implement here rule 10. Repeat quickly on rule 10. According to rule 10, rule 10 is true in any circle. So in any circle, if AB is a chord, you can see that AB is a chord, and PT is tangent to this circle point T. Then in this drawing, if we have chord AB and tangent PT, we can implement the rule 10 here. According to rule 10, the following equation is true in this drawing. PT square equals to PA times PB. Again, PT square equals to PA times PB. So we can definitely implement rule 10 in our drawing. Why? Because in our drawing, if we focus on this common example point B, from this common example point B, we have tangent BP that is tangent to this circle, to this green semicircle at point P. In addition, from the same common example point B, we have chord CA. Again, from the common example point B, we have tangent BP, and from the same common example point B, we have chord CA. So all the requirements of rule 10 are satisfied, and therefore we can implement a rule 10. According to rule 10, the following equation will be true. BP square equals to BC times BA. Again, BP square equals to BC times BA. And again, according to rule 10, the following equation is true, that BP square equals to BC times BA. This equation is the implementation of rule 10 in our drawing if we focus on the common example point B. So BP square equals to BC times BA. BP square, BP is the missing tangent, so we leave it as it is. So BP square equals to BC. BC is 1, so I'm solving BC by 1 times BA. BA in total equals to 1 plus 5, that is 6. Again, BA in total equals to 1 plus 5, that is 6. So 7 BA by 6. So So in conclusion, I should have found out that BP squared equals to 1 times 6, that is 6. 1 times 6, that is 6. BP squared equals to 6. We took out all those equations and finally found out that the missing tangent BP equals to the square root of 6 units in its length. This is the missing tangent BP. This is equals to the square root of 6 units in its length. In the next step, I copied this right triangle APB in a new page and implemented the Pythagoras theorem on this right triangle APB. Actually, we know that the hypotenuse BA equals to 6, side PB equals to the square root of 6 units in its length, and the only missing side is side AP. So we can find out the missing side AP by implementing the Pythagoras theorem in this right triangle APB. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So actually, this is a right triangle APB that I copied from the original drawing, and I repeat again that BP equals to the square root of 6 units, the hypotenuse AB equals to 6. According to the Pythagoras theorem, in this right triangle APB, AB square equals to AP square plus PB square. Again, AB square equals to AP square plus PB square. AB is 6, therefore AB square is 6 squared, that is 36. And it is equals to AP square. AP is the missing side, so we leave it as it is, plus PB square. PB is square root of 6, therefore PB square is square root of 6 squared, that is 6. So in conclusion, we actually found out that 36 equals to AP squared plus 6. Here we subtracted 6 from this equation and finally found out that AP squared equals to 36 minus 6 is 30. So AP squared equals to 30. We took out all of this equation and finally found out that the missing side AP equals to the square root of 30 units in its length. This is the missing side AP that is equals to the square root of 30 units in its length. What is the definition of AP? AP is the diameter of this green semicircle. If AP is the diameter, it means that AP over 2 is the radius. Again, AP over 2 is the radius. So the radius R of this green semicircle equals to the diameter AP over 2. AP equals to the square root of 30. So the square root of 30 over 2 is the radius of this green semicircle. So the radius of this green semicircle, R equals to the square root of 30 over 2. Our mission is to find out the area of this green semicircle. The area of this green semicircle equals to pi r square over 2. Repeat again. The area of the green semicircle equals to pi r square over 2. And we already found out that the radius R of this green semicircle, the radius R equals to the square root of 30 over 2. So the area of the green semicircle equals to pi r square over 2. It is equals to pi, R is square root of 30 over 2, therefore R square is square root of 30 over 2 square divided by 2. So the area of the green semicircle in total equals to pi times square root of 30 square is 30 over 2 square is 4 divided by 2. So the area of the green semicircle in total equals to pi times 30 over 4 over 2. 30 over 4 over 2 is 30 over 4 times 2. So in total, the value of this expression equals to 30 pi over 4 times 2. Here 30 over 2 is 15. So in total, the value of this expression equals to 15 pi over 4. So 15 over 4 is 3.75. Therefore, in total, the value of this expression equals to 3.75 pi, or 3.75 pi is 11.78. So in conclusion, in both methods, we found out that the area of this green semicircle equals to either 3.75 pi square units, or in terms of numbers, it is equals to 11.78 square units. Again, in both methods, we arrived to the same result. Okay, thank you very much.